In this video I'm going to show you how to do question 12 from Edexcel A-Level Maths, Pure Maths Paper 1, June 2018. My name is Sunil Tanna. I'm a tutor and author. My details are on the card. I'm available for one-to-one tuition, both in person and online. For in-person tuitions, I live in Buckinghamshire, England. Let's get started. The value V of a vintage car T years after it was first valued in January 2001 is modelled by this equation. Given that the value of the car was £32,000 on January the 1st, 2005 and £50,000 on January 2012, find P to 4 decimal places and later on show that the value of A is approximately 24,800. Okay, so if we write down the information in the question as equations, we can see that in 2012, in other words 11 years after the first value, A P to the power 11 will be equal to 50,000. Likewise, in 2005, which is 4 years after the first valuation, AP to the 4 was 32,000. So we've got two equations and two unknowns. Now for these type of equations, the easiest way to solve them is by dividing. So if we divide the first equation by the second equation, we'll have A, and the A's will cancel out, P to the 11 divided by P to the 4, which gives us P to the power 7. And if we do this division on the right-hand side, we get 1.5625. Now to find P, we need this number to the power 1/7. So P is equal to 1.5625 to the power 1/7. We can use our calculator to calculate that, and we'll see it is 1.0658 to 4 decimal places as requested. Now we have to find the value A, the initial value of the car. So let's label that, that's A part 1. For A part 2, we already know that AP to the 4 is 32,000. So A is 32,000 divided by P, which we actually have here, to the power 4. So 32,000 divided by this number to the power 4, which we can type into our calculator, and it comes out to 24,796.80. So we can see that A is approximately equal to 24,800. Okay, now going to do part B of the question. So to save flipping the pages, I've got another copy of the question so we can look at both things together. So the next part was, with reference to the model, interpret the value of the constant A. So for B1 is the value in 1st January 2001. That's the initial value. For B2, the value of the constant P. It's the common ratio. We multiply this by the price by this value every year. So it's the common ratio. So multiply price by this each year. Okay, and we're now ready to do part C. Again, I've got another copy of the question, so we don't have to keep flipping between pages. So let's do that. Question part C. Using the model, find the year during which the value of the car fast exceeds £100,000. So that will be the first year in which V is greater than 100,000. And since we know V is A times P to the power T, it has to be greater than 100,000. So the first thing we can do is divide both sides by A, which we already established was approximately 24,800 or 24,796.80. So P to the power T will be greater than 100,000 divided by 24,796.80. So P to the power T is greater than, if we put that into our calculator, we get 4.03277 8. Now this is a inequality that we'll need to solve using logs. So we're going to take a log of both sides. So log of p to the power t is greater than log of 4.0327778. Using our laws of logs, we can take the t out the outside of the log, so it'll be t times log of p. Remember, we have already established the value of p in part B2 of the question is greater than log of 4.0327778, and t will be greater than log of 4.0327778 divided by the log of the value of p that we determined p earlier. Is that so? You can use the previous answer button on the question when working out log of p. So you'll find that t has to be greater than 21.88. So what that means is that 21 years after the start, the value has not reached 100,000, but 22 years after the start, it will reach 100,000, or it will exceed 100,000. So we can see that 21 years after the start will be sometime during the year 2022. So year is 2022. And that's the end of the question.